Hello, today we're going to talk about section 8.11, which is on pH and how it relates to solubility. So we're going to be connecting this to KSP. So this is effectively an application of Le Chatelier's principle. Let's look at a solubility reaction here. Say I have calcium hydroxide, which is only slightly soluble. It can break apart slightly into its ions, calcium ions and 2 hydroxide ions. So if I were to write my KSP expression for this, I would have the calcium ions times the hydroxide ions squared because of the coefficient of 2. Now, because one of my ions is hydroxide, it is affected by pH. When pH increases, you're going to have less hydrogen ions or more hydroxide ions. When pH decreases, you will have more hydrogen ions or less hydroxide ions. So in this case, I'm looking at the hydroxide ions part of this. So if I were to increase the amount of hydroxide ions at a higher pH, it's going to shift it to create more of the solid precipitate. And that's effectively the common ion effect. Now, if you were to have a lower pH, more acidic solution, then there would be less hydroxide ions in the solution, and that's going to shift the equilibrium so that more of the precipitate dissolves. So let's look at a couple example questions. There's an equilibrium here, and it has 2 colored species. The CrO4 negative is yellow, while the Cr2O7 is orange. So we've got chromate and dichromate ions here. Now it says predict the color in the reaction vessel after each of the following additions to a system at equilibrium. If you're adding in sodium hydroxide, that's more hydroxide ions or less hydrogen ions, because the hydroxides will react with hydrogen to form water. So if I'm removing hydrogen ions from this equilibrium, that's going to shift it back towards the reactant side, and you will wind up with a more yellow solution. For B, if I add in HCl, I have more hydrogen ions or less hydroxide ions. More hydrogen ions is going to increase the amount of reactants, which will shift it towards the product side and create an orange solution overall. Now in this example, we have multiple equilibrium systems happening in the same container. So you have calcium carbonate forming calcium ions and carbonate ions. But you've also got some carbonic acid going on because of the carbonate ions in water. So it says, what will happen to the concentration of calcium ions when the pH of the solution decreases? pH is decreasing, that means I have more hydrogen ions. So if I have more hydrogen ions, here it's going to shift it to the reactant side, which takes away some of this hydrogen carbonate. That decreases the amount of hydrogen carbonate, which is also going to shift towards the reactant side, and you'll have less carbonate ion. If I have less carbonate ion overall, that's going to shift my equilibrium position towards the products, and so you will have less precipitate and a higher concentration of calcium ions.